Today, I'm going to be talking to you about building consistent cross-platform interfaces. I just want to start by saying thank you for staying all the way to the very end. I know OSCON is a long conference, and I probably might not have made it to the very end if I weren't talking at the last slot, but here we are. So again, thank you. Hopefully this will be fun and entertaining and very informative. So here's some links. The top one is the actual kind of like interactive slide presentation. It's a React-based web application, so you can press like left or right to move through the slides. The second link is just a PDF export if you're not into doing interactive slides. And I am dbanks design on Twitter, GitHub, other things. So you can tweet at me. If you tweet about this presentation, use the OSCON hashtag. All right, so now that stuff is out of the way, a little bit about me and why I'm here today. I work at a company called Amazon, and specifically I work on the mobile app that third-party sellers use to sell stuff on Amazon. List products, ship orders, message buyers, advertise their products, that type of stuff. And to give you some background, our organization is very large. We have a lot of teams building a lot of features in both the mobile application and the web application that third-party sellers use. And over time, with so many people and so many teams building features into these applications, something like this inevitably happens. This is just a sampling. Let me refresh so it gets bigger. There we go. This is just a sampling of the colors that were used in our Android, iOS, and web applications. And it's not just colors, but fonts, icons, sizes. All of the styles of the interface really kind of decayed over time. And this is a symptom of a larger problem of not having a good structure or mechanism to maintain styles, especially across platforms, applications, code bases, teams, etc. And to show why this is important, there's a great quote by Jacob Nielsen. Consistent experiences help users build trust with the organization. Each interaction is part of the overall user experience with the company. If the user experience isn't consistent across channels, users will question the organization's credibility. And so I highlighted consistent experiences and across channels here, because if you have a web application that looks nothing like your mobile app, or your desktop app looks nothing like your watch app, it makes your product or your brand or your company really look unprofessional. And I do want to clarify consistent experiences here, because in my mind, consistency does not necessarily mean that everything has to look exactly the same. So mobile apps don't need to be a shrunken version of your web app. An iOS app doesn't need to look exactly like the Android app. Your marketing site doesn't need to look exactly like your application. But rather what we should be striving for is to be a good platform citizen. And what this means is an iOS app looks like an iOS app, and an Android app looks like an Android app, and a web app looks like a web app. But they all look like your product on that platform. This way your users feel at home in their given platform while still feeling like they're using your product. And there's an analogy I like to use to help explain this as well. These are all BMWs. Most people could probably tell that these are all BMWs if you know cars. And car makers usually have a very definitive style. These are recognizable as BMWs, even though they each have their own characteristics. They're not clones of one another. And your product or your brand or your company is like a car manufacturer like BMW. And your applications or your customer touch points are like specific models of cars. They all share the same style and essence, but they don't need to be clones of one another to feel consistent. So hopefully that makes sense. And so let's kind of put this into practice. Say we have a web application, an iOS app, an Android app, and we have internal design resources that our designers use. Maybe your web app uses React and CSS, your iOS app uses Swift, your Android app uses Kotlin, and your designers use Sketch. How do you get all of these things talking to one another? There's some one-off solutions like going from Sketch to React or React to Sketch, but they don't solve the larger problem of connecting all of these things together. And so, if you wanted to say change your brand color for your company, maybe your designers change their sketch file, but that change isn't reflected in all of the places that you actually use those brand colors. And so to do this, to solve this problem, we need what's called design tokens. Show of hands, has anyone heard of the term design tokens before this? All right, 2 people, cool. So I'm gonna explain kind of what design tokens are. So first, let's take a look at the definition from the Lightning design system built by Salesforce. They're the team and company that actually created the concept of design tokens. And so they define design tokens as the visual design atoms of the design system. Specifically, they're named entities that store visual design attributes. So basically, design tokens are key value pairs that store design attributes or visual attributes. Simple enough. Let's build on this definition a little bit more. This is written by one of my colleagues at Amazon who has done a lot of work in the design token space, and he defines design tokens as variables that codify every aspect of a design in a platform-independent format that is readable by both humans and machines. So basically, kind of merging these 2 definitions together, we have something that's platform-independent, key value pair, and is readable by both humans and machines. So what types of information can we store in these platform-independent named visual design attributes? We can store things like colors, typography, iconography, motion, dimension, elevation. Basically, anything that you could put in a CSS property, borders, widths, sizes, could be a design token. And so while we're kind of talking about CSS, what makes design tokens better than just using CSS variables or SAS variables, for example? So there's 4 key properties that we're going to look at. And the first one is design tokens are canonical. They're a single source of truth, and because they're a single source of truth, they have different representations or different interfaces in different languages and platforms. So I'll show you an example of what this looks like. Take this teal color as, say, your brand's primary brand color. Now, if you want to use this on the web, maybe you define a SAS variable like this. You give it a name, you give it a value, it's a hex value, color brand primary. Simple enough. If you want to use this on iOS, if you're using Objective-C or Swift, you define a UI color instance with red, green, blue, and alpha channels. But these channels are based out of 1 and not based out of 255 like you would if you were using RGB in CSS. And if you were to use this in Android, you'd define a resource or an Android resource XML. And what's interesting about Android is you can use an 8-bit hex, so a hex value with 8 characters. And the alpha channel is actually at the beginning, not at the end, which is where it would be in other languages. So Android is kind of weird in that way. But as you can see, they're all referencing the same thing, right? They're all that color, but they're just different languages for doing that. So it brings me to the second point, which is design tokens are agnostic. They can be used anywhere, in any tool, any platform, any language. And this is important because here are just some of the languages and frameworks that you could use to write UI code in. And new frameworks and languages are being written every day. Most recently, like Swift UI came out at WWDC, looks super cool. But I will say there's never gonna be one of these that beats the other ones. We're not gonna only write Flutter from now on or only write Swift. There's a space in the industry for all of these things to coexist. And the same can be said about design tools. We used to just have Photoshop and Illustrator. Now we have Framer, Figma, UXPin, Adobe XD. And none of these are gonna just win and kill all of the other ones. We want choice. Like some people might prefer Figma over Framer, and that's cool. So we need the design tokens to be a universal interface between all of these things so that if one designer uses Figma and one uses Framer, we don't need to have duplicate copies of everything. And same with our actual interface code. The landscape is always changing, so we need something that's static and consistent across everything. And third, design tokens are structured. They're categorical. there's different types of design tokens which can interact and behave differently. If anyone remembers the biological classification of organisms, kingdom, phylum, class, etc., it's known as a taxonomic hierarchy. So you group things into smaller and more specific buckets, with the most generic you can get at the top and the most specific at the bottom. And so we can use this classification system to, we can apply it to design tokens or visual attributes. So starting with the most generic, we could think of a way to categorize visual attributes. You could think of time or color or size. And these are just kind of an example. But we could take color and we could say, what type of color are we trying to define? Are we defining a border color, a background color, a font color? And we can keep doing this, but we know that everything under the color namespace is going to be a color, but they're just different types of colors. And so you could say, it's an alert background color, and it's a success alert background color. And so this structure it gives us a way to define and name tokens in a way that is consistent and it's easy to reason about. So we can know that everything under the color namespace is a color. And this kind of taxonomic hierarchy, this structure, brings me to the last and potentially most important concept, which is design tokens are relational. They form meaning by referencing other design tokens or referencing themselves. And this allows for the right level of granularity and flexibility when you want to change the styles of an interface. And I'll show a couple examples of what this looks like. So say we define like a core color palette. We have teals and greens and blues. And we have different shades of each color. This is just one, this is teal 100. We have teal 80 and teal 40. So in and of itself, it doesn't really carry much meaning. It's just saying this is a shade of teal. But we can layer meaning on top of it by saying our primary brand color is the teal 100 color. And then we can layer even more meaning on top of that by saying the button background color is the primary brand color, which is teal 100. And same with the link font color. Now, if we want to change what kind of shade that teal 100 is, we could make that change, and that structure is still reflected. That change flows through all of the other tokens. Maybe we don't want to change the core color palette, but we want to change our brand color from teal to orange. We can do that as well, and the structure kind of remains intact. And this concept is sometimes referred to as design options versus design decisions. The core color palette are design options. They don't say how you should use it. They just say, here's all the colors that we have. But the button background color is a design decision. It says this is how this color should be applied. And so these kind of separate a little bit of the meaning between different types of design tokens. I'll show another example of what this looks like. So again, here's kind of a core color palette. Here's a bunch of grays, 140 to 10. And again, they don't carry much meaning in and of themselves. You could apply this color palette to different interfaces. You could say gray 140 is the background and gray 10 is the text color, and you have like a dark themed application, or you could reverse it and you have a light themed application. So these are just design options. But we can layer meaning on top of them by saying our text color palette, primary, secondary, tertiary, relates to gray 120, gray 80, gray 60. And we can layer even more meaning on top of that by getting into very specific uses and saying our input text color is text primary, which is gray 120. And our disabled input is text tertiary, which is gray 60. So if we wanted to, we could change the core color palette. We could change all of these grays, and that would affect text colors, background colors, border colors. Or we could have a more localized change and say, change the tertiary text to gray 40 instead of gray 60, for example. So we have these kind of different layers of changes that we could make that affect all of the interfaces in different ways. We could have very broad reaching changes or very hyper-local, hyper-specific changes, like just changing the input text color. And so adding all these 4 attributes of design tokens up, we get a system that is consistent and maintainable across all platforms, languages, instances, artifacts. and we can make a change in one place and have it reflected everywhere that we need it. It's resilient to changing technologies. When a new tool or framework comes out, we don't need to worry about copying a bunch of information over to it. We're pretty resilient to changes in that way. And it's flexible to allow the right level of change in design. So we can change, the core color palette, which has a very broad reaching change, or we can make a very specific change, but it kind of codifies that system of what we're trying to change in a very systematic way. So going back to our products again, our web, iOS, Android applications, design tokens would be a single place that all of these things reference, so that if we wanted to make a change to, say, our brand colors, we can do that in one place and have it reflected everywhere at the same time. So up until now, this has been a bit conceptual, but what are design tokens actually like? How are they implemented and how are they used? So design tokens are, going back to our definition, they're just definitions stored in a standard human-readable, platform-independent data format such as JSON or YAML. And that's mostly it. There is some untapped potential. It doesn't quite meet the definitions that we had earlier, but at its heart, this is what it is. Because JSON or YAML, they're human readable, they're platform independent, they're not tied to any tool or framework or UI. So now that we're kind of defining our styles or our design tokens in JSON or YAML, how do we actually use them in our iOS app or our Android app? So say on the right here, we have our design token files, our colors, our font sizes, our icons. So the first step to using them is we need to transform them. We need to transform the tokens themselves. So for example, hex values become RGB for a certain platform, or pixels become points, or seconds become milliseconds. And then once we transform all of the tokens, we format them into specific files, like a CSS variables file, or a JavaScript object, or an Objective-C header file, or an Android resource XML. And so we do this as many times as we need to generate all of the artifacts that we need to be able to use it in the platforms that we're trying to use it in. And so really what we're doing is we're generating build artifacts from these data files that are then consumed in the different environments. We're dynamically generating code files. And so we can do that as little or as much as we need to. We can generate hundreds of files or 3 files. And so kind of taking this concept, how do we actually do these transform and formatting steps? Sorry. So the first is you could write a custom build script. Here's 2 GitHub repositories that do just that. If you have the presentation slides open, these actually link to the GitHub repositories, or you can just search for these things in GitHub. That's one way you could do it. It's not super complicated to write these build scripts, and these ones still roughly follow the same pattern of transforming and then formatting the tokens. Another way you could do it is you could use a framework. And the first one I'm going to talk about is Theo. It's an open source framework built by Salesforce and the Lightning design team, who invented the idea of design tokens. And it is JSON or YAML based. There's a command line interface as well as a node module. And it uses transforms and formats with customization, just kind of like that build diagram. And it has a pretty great community behind it. So here's just a quick example taken from their README. So they use YAML files. At the top right, we're defining some aliases, and at the bottom right, we're using those aliases in a button file. And then on the left, we're actually converting that button's YAML file. We're transforming it for the web, and then we're formatting it for SCSS. And then at the bottom, we get that output of these SAS variables. And so that's one way to do it. The other way, I've worked on a library at Amazon called Style Dictionary. it follows the same patterns as Theo and Ezo's custom build scripts as well. So all of the kind of examples and code in here will be applicable to everything. And same with all of the concepts, they all kind of share the same ideas. So let's get started with kind of going into style dictionary. I'll go into some code really quickly. There's a lot of stuff I'm just going to kind of gloss over, but I'll hit the main points, hopefully. So first thing, requiring the style dictionary module. Again, it's a node module, but you can also use it as a command line interface. And then we define the configuration. So it just takes kind of like a configuration object and tells kind of style dictionary what we're trying to do with it. So the first part of the configuration is to give it a source. So this tells style dictionary where to find all of your token files, and style dictionary will take them and they will merge them all together. So you have one big like dictionary object to build from. And then you define platforms that you want to build to. And platforms here it's not like Android, iOS, web. They could be anything. You could have 100 platforms. You could have 3 platforms. You could name them whatever you want. Really, they're just groupings of transform and build configuration. So taking this SCSS platform, we give it transforms that we want to apply to all the tokens. The transforms are applied in order. So the kind of output of one can be in the input of another. And then we can give it a build path where we want to actually build all the files that we're generating. And then we give it some files to build. So we give it a destination. We want to build a CSS file. And we want to use the CSS variables format. So we'll just output a list of CSS variables. And then we just call the build all platforms method. And then it'll actually go through and build all of those platforms. You can also use an external configuration in an external file as well. So moving on to kind of the design token file itself. It's a JSON file. It's just a nested object. There's nothing inherently special about it. It's just a nested object. The only thing that kind of really matters is any node in the object that has a value attribute that tells the system that this is a design token. So that, this is a design token, everything else is just kind of structure. And you can reference other design tokens in the value. And because style dictionary is merging all of the token files together, they don't need to be in the same file to be able to actually use them or reference them. So they could be across any file that it finds. And you can add extra metadata like comments or any extra attributes that you want to add that you might use later on for documentation or anything else. And tokens can be nested at any level. You could have, 20 levels deep of tokens or just, 1 level deep. It's very flexible. It's very up to you to decide what you want to do. So given this, single design token file, you could get outputs like SAS Variables file. So here we're just outputting some SAS variables. If you notice, this is a flat list, whereas this is an object structure. So style dictionary will take the object and find all of the tokens and create a flat array. So you can output just a flat array of variable files or variables. And if you notice, the name of the variables references kind of the object structure. So size font small, it makes the variable name size font small. And on web, we're using the rem unit. And you can see like the comment is still there from here. And also for iOS, maybe we want to output just some floats. iOS doesn't have a concept of a rem unit, so we multiply all of the values by 16. And also iOS doesn't like dashes in variable names, so we use Pascal case. But you can see it's the same data, but just formatted differently. And same with Android, we're using the SP or scale independent pixels unit because Android doesn't have the rem unit as well. And similarly, again, we're kind of using the same name structure, but using snake case here. So all these kind of are built from the same data, but they're slightly different based on the platform that we're using them in. So going back to this build diagram, I'll go into the transform and formatting steps a little bit more to kind of see what they're actually doing. So starting with transforms. So transforms, again, they modify the design tokens, so the tokens themselves can be used on a given platform or language. And Theo shares the same concept. They call them transforms as well. Or if you're building your own system, it helps to think about transforming the tokens specifically. So here, we're going to define a custom transform. Both Theo and Style Dictionary have predefined transforms built in for a lot of the common ways that you would want to transform a token. But just for an example, here we're defining a custom one that we're going to use. So first, we give it a name. We reference this name in the configuration. If you remember back, you kind of define an array of transforms that you're going to apply. So you can just give it this name, and it will apply that transform. Transforms have a type. You could transform the value, you could transform the name, you could add extra attributes to the token. And transforms have a matcher function. So this will tell the system if the transform should be applied to a given token. So it might not make sense, obviously, to try to turn the number 5 into an RGB string, because that wouldn't make sense. But so you can give it a matcher function that says, I only want this to apply to colors, for example. And because the transforms are applied in order, you can reference like extra attributes that are added onto the token from previous transforms. And last but not least, the transform function that actually does the transformation. So this is just taking the value and turning it into an RGB string. So if the value was this hex value, it would turn it into that RGB string. And you can also do like name transforms if you want to transform the name for snake case like we did for Android. If you don't supply a matcher function, it will apply to all tokens it finds. So that's helpful if you want to kind of name the tokens in a specific way. And next we have formats. So again, the tokens are transformed first, and then we format them all into specific files. While the transforms focus on the design tokens themselves, formats kind of put them all together. So CSS and JavaScript could use the same transforms, but they would need different formats to output like a JavaScript module versus a CSS variables file. Adding a custom format is similar to adding custom transform. Again, there's pre-built ones in Style Dictionary and Theo, but just for an example, we're defining a custom one here. So we give it a name, which we reference in the configuration again when you say file destination and file format. You just give it this name, and then you give it a formatter function, which takes in the already transformed dictionary, and then it outputs a string, which is then written to the file. And so the dictionary has both a flat array, which is under all properties, or the actual kind of unmodified object structure. So this format is basically just saying, I'm going to output all of the tokens and do a SAS variable declaration. And you can also use handlebars or mustache or any other templating language that you want, as long as obviously you require that node module. And all right, so demo time. Hopefully this works. This is a React-based web application. I'm running this locally on my laptop, and it's depending on a style dictionary to define all of its styles and colors and font sizes. Let me move my mouse over here. Oh, wait. I also have an Android and iOS app running locally in emulators. These are just plain Android and iOS applications. They're not React Native or anything like that. They're straight, Objective-C and Java. So going back here, here's kind of where I'm defining my brand colors, teal and purple. So if I want to make a change, this is going to be kind of a drastic change, just to kind of, for it to be very visible. But if we want to change teal to red, and purple to blue, I will save that. I just have basically a couple watchers watching for changes and then to rebuild. So this one just watches for changes to the style dictionary token files, and it will rebuild the style dictionary. And then these two are looking for changes to Android and iOS, and they'll recompile the Android and iOS binaries. So going back here, the Android app is already updated. We're actually generating images based on the colors. And so you can see the red and blue colors, and we actually updated the app icon as well. So same with iOS, we're using kind of red and blue. We're using them in like slightly different ways. So, and our presentation is also updated. So just making that one change and then kind of seeing it reflected. And we can do another change as well. So let's change the font from Open Sans to Ubuntu. And I'll save that. Again, waiting for changes, rebuild a bunch of files. Going back here, it should already be updated. It's kind of a little bit harder to tell, but the font is actually different. And going back here, the font is updated in the Android app, and once the iOS app rebuilds and relaunches, that will be updated as well. So we can make changes to icons, fonts, images, colors, font sizes, anything that you could describe in sort of like a visual way. You could put it in Style Dictionary and have it used in any platform. So again, using fonts here. And that's it for the demo. So I have some resources as well. So the first one, again, if you're opening this, these are all linked to the proper places. The first one is a GitHub repository called Awesome Design Tokens. It has basically articles, talks, examples of design systems using design tokens. A lot of great resources if you're interested in learning more about design tokens. The next one is kind of a personal plug. I just wrote an article called Documenting Design Tokens, and it's a pretty long article and it's pretty exhaustive. I have tons of like image examples of how design systems are documenting their design tokens, like what types of features are they using, like copy buttons, searching, that type of stuff. So it's a pretty in-depth article if you want to look into how to document design tokens in your design system. Third, the Design Systems Handbook. It has more than just design tokens, but it's a great resource. It's a free book written by Envision, and they do have, I think it's a section of a chapter on design tokens. Next, we have an article written by someone in the UK about how their company uses Style Dictionary, and it's a very in-depth, very like technical, specific way of how they're kind of setting up their Style Dictionary and design token setup. One of the things that's really cool about design tokens is everyone's setup is very different. Everyone has very different needs, and they're all sharing the same concepts. They're all using them the same way, but how they set them up is very different. So for example, their setup, they have multiple brands, and so they have design tokens for each brand, but then they reference those brand tokens, and they have this crazy kind of complex build system that they use. And lastly, the design.systems Slack group, whatever a Slack thing is called. It's a public one. You can just enter your email and someone will approve you and you'll join. There's over 10,000 people from all over the world. It's a really great resource. Everyone's really nice and friendly. You can just ask a question like, hey, how do I do this? Or what does everyone think about that? And people will respond pretty quickly. There's a lot of channels for, tools like Style Dictionary and Theo, for topics like design tokens or color or code, for specific cities like Seattle or Portland or San Francisco. So it's a really great resource. I've met a lot of awesome people in it. So I'd highly recommend anyone that's working in sort of design systems or even just curious about design systems to join. And that is it. I want to say thank you again for sticking it through to the very end. I'm also supposed to tell you if you liked this talk or hated it, give feedback in the OSCON web app or OSCON mobile app. That feedback will help me improve this talk for when I give this in the future. It'll also help OSCON decide what talks are good for future versions of OSCON. So if you hated this talk, give me that feedback. That's very helpful. Also, if you loved it, that is also helpful as well. You can also tweet at me and tell me that it was good or bad. It's fine. And I'm just going to leave up this information. Again, links to the slides, links to my information or style dictionary or whatever. I think there's like 5 minutes for me to take questions, but also because this is the last talk, I'll just be hanging out and you can ask me questions in person. I also have stickers for style dictionary if anyone wants a style dictionary sticker. And that is it. Thank you so much.